All right, welcome back. What we have here is another integral, and we're going to try to talk about how to solve this one. Well, like any problem, you come to the problem and you want to try to figure out what is this integral going to be. If you do this long enough, you can probably figure out like enough. But going through the process, we have basic, go through and say, okay, is this a basic integral? Okay, so I'm going to kind of just go through a basic steps. All right, basic integral. Not really, not really. I don't see anything basic about this. We have x squared plus 2x. So I'm going to say, can I use the natural log? You cannot do that. Don't do that. That's bad. So no, not really. Okay, so we go no. So what's the next thing? Well, use substitution. Now, if you looked at my other past tutorials, use substitution, normally what I would do is I would probably pick a u, because I always want to try that first. And in this case, I'd probably pick the denominator. So I go x squared plus 2x. I put that in there, and I'll take the derivative. So I have du equals 2x plus 2, the quantity times dx. So we'll have that right there. This right here, I need to replace this with something on the top, and it doesn't appear I can do that because I don't have this portion in there. So u substitution is probably also, in this case, a no. Oh, man. We then have parts. Parts, we're going to have u times v. All right, u times v. So I need two things being multiplied. I don't really have u times v, so I don't even know what to pick for u, question mark. So no for parts as well. What do you do? All right, well, in this one, we notice that we have a fraction. Okay, there's a fraction. Since there's a fraction and u substitution does not work, and it's not a basic integral, we're going to try what's called partial fractions. All right, partial fractions. In these partial fractions, we're going to be using, so to use partial fractions, what we're going to do is we have to first factor the bottom. So we're going to write this expression as, I'm going to put this a different color. We have the integral of dx, and we're going to factor out an x, and we have x plus 2. So we have the product of two linear factors in the denominator. Now, what we're going to do is we're going to divide this. That means we're going to separate this apart. Now, to do this, this is an algebra trick. We're going to take and create two different fractions, one for each um, uh, one of these factors in the denominator. Okay, these linear factors. So I'm going to have ax plus b times x plus 2. Now, from here, this is actually going to equal 1 over x times x plus 2. So essentially, I'm doing algebra right here. So this is the algebra, all right? So I can create a simpler expression to take the integral of, okay? Now from here, what we're going to do is I'm going to try to eliminate these denominators. So I'm going to multiply both sides by this expression right here, okay? When I do this, when I multiply this entire expression by the denominator, all right, this is what we have. This is going to turn to 1. Over on this side, we distribute this over here, and that is going to be a times x plus 1. Well, the x's will cancel out, so we're left with a times x plus 2. I then multiply this by this expression, and you realize that we have b, and then we're going to have a bx. And we have that because the x plus 2's cancel out. And like you said, I multiply it here, and then you just have 1. Now, from this expression, I'm going to distribute, we have ax plus 2a. It's going to be plus bx equals 1. From here, I'm actually going to do a little bit comparing. I'm going to create a system. I'm going to group all my x's together. So I have ax plus bx. And what I'm going to do is, if you notice over here, that I don't have any x terms, because these two have to be equal, right? Because it's an equation. Well, 1 has to equal this expression right here. Well, ax plus bx, that has to equal whatever coefficient next to x. Well, there is no coefficient next to x. So guess what that coefficient has to be? 0. So we're going to make this equal to 0. That's where we create our first combination. The next thing we're going to do is over here, all right, or actually, and then the next one over here is that I have, well, 2a. Well, 2a is the only constant in this expression, or in this equation. So that has to equal our only constant over here, which is 1. From here, we're going to solve. So what we have is, I'm going to need to figure out what A, B are going to be. Well, A, this is pretty easy to figure out, is going to be 1/2. If A is 1/2, what does B have to be? Well, if I plug those values back in there, okay, I'm going to change the color. So if I have 1/2 of x plus bx equals 0, and I usually factor out the x's just so you know. So I have 1/2, and if I factor out the x's, I'll have 1/2 plus b times x. You don't have to do this, but I'm just doing it. And usually I divide by x to just eliminate it, so I just have 1/2 plus b equals 0. Well, what does b have to be? Well, you can obviously see, probably even in this first one, b is going to equal negative 1/2. And that's what we have for our solution. Well, once we have that as our solution, we can go back up here. So we have a is 1/2, b is negative 1/2. We can now plug that in there and then create our new expression. And that's what I'm going to do right here. I'm going to actually erase this, all right, because using the partial fractions, I am now going to replace all this stuff, and I'm going to write my new expression. So what was A? A was 1/2. So I'm just going to put 1/2 on the side. 1/2 times 1 over x. And I'm going to go plus, and what was b? B was negative 1/2, so actually I'm going to go minus 1/2 times 1 over x plus 2. And that right there, my friends, is all going to be multiplied by dx. By doing this, now I can simply take this 1/2 and take the integral of each one of these separate expressions. The integral of 1/2, 1 over x, is going to be 1/2 natural log of x. Minus, I have the 1/2, and I'm going to have natural log of x plus 2 plus c for my final answer. And that is how we use partial fractions. The key thing is separating and using partial fractions to separate this, all right? And then once you get that, finding a, b, or c, depending on how many numerators you have, so then we can use that to simplify and create a simpler expression that we can integrate rather easily. All right. Well, I hope this helps you out. At least it gets you started. And I'm going to have some other tutorials on this and how to do these different things as well. All right. Good luck and God bless.